Hello, sir.
Yes.
Gonna solve sums, sir.
What?
Are we going to do more problems today?
Yes, yes. We will solve the problems. So this is visible. This photo is visible.
Yes, sir.
Now, what is the answer for first one?
It's the now only I'll take. Sir, yes, sir.
Huh? First one. Yes.
Yes, sir.
Yes, yes. So here, this is written as square root of x. So what is the domain? That means this quantity should be positive. So that means x should be greater than equals to 0. Positive or 0?
Yes, sir.
First one is correct. Second one, 1 upon x minus 2.
B.
So x cannot be equals to 2. Right? So third one, square root of x square minus 1. Square root of x square minus 1.
Greater than 1. Greater than or equal to 1.
Square root of x square minus 1 means this quantity should be positive. So x square minus 1 should be greater than equals to 0. So we can write down this as x minus 1 into x plus 1, then equals to 0. So this is minus 1, this is 1. So this is positive, negative, positive. So positive 1 is
Sir.
the function, right? So it is saying consider a composite function square root x square. What is the domain of this function? So
No option.
yeah. So here there should be an option r minus 1 to 1.
Or can we write B and C, sir?
Which one?
B and
C.
C.
But C is not correct. X is less than C. X is less
Oh,
than
wonder, sir.
equals to minus 1. So this is 1. Okay.
Oh, okay, sir.
Okay, next question.
Log x minus 1 should be greater than 1, greater than 0. Sir, B.
Question number 4. Log x minus 1. So here log x minus 1. Right? Here it is written log. Base is not given. So I'm this is the question from chapter relation and function. That means from calculus. So we can consider here base as e. Right? So also no need to consideration of base also. Only argument should be we can solve only all the arguments. So x minus 1 should be greater than 0. So x should be greater than 1. Log is only defined when argument of this log is positive number. So x should be greater than 0. This one is the correct option. Right?
Yes, sir.
Next. 1 upon sin x. What is the domain for 1 upon sin x?
1
What
upon 7.
what
So
is the
sec
domain?
x domain
In
is
case of 1 upon sin x cannot be 0. Because 1 upon x, 1 upon 0 will be undefined. So 1 upon sin x, this will be only defined when sin x is
sir,
not
option
equals to
C.
0. So when sin x equals to 0, sin x is 0 for x equals to n pi, right? So that means x cannot be equals to n pi. So this one is correct. Next, what is the domain for next question? 1.
1 minute, sir.
So again, this expression is only defined when the denominator is not equals to 0. So denominator should not be equals to 0. So when for which values of x, this expression is 0. This denominator is 0. Right? So here,
Sir, A, sir, option A.
when x square minus x minus 6 is 0.
Sir, option A.
Option A. That means you will get factors like x plus 2.
C. Option C, sir. Sorry, sir.
Option C, yes. X plus 2 into x minus 3. These are the factors. That means x cannot be equals to minus 2 and x cannot be equals to plus 3. So except these two values, this expression is defined. So our real number minus 2 to 2 and 3. Minus 2 and 3, right? Next. This domain, second question.
1 minute.
Is that
So
so?
1 upon box x,
R minus is it?
right?
Option C.
Here, there is one statement which is missing here. There should be this type of
R minus D,
statement should
sir.
be there. That box x is GIF, yeah, right? This should be given. So now considering this function as fraction greatest integer function. So for which
Sir,
value
C.
of x this is defined?
C.
C.
Option C.
Option C, R minus Z. See, if I take here x equals to minus 3. So minus 3 box minus of minus 3. So you will get minus 3 plus 3. So this will become 1 upon 0. 1 upon 0 is undefined. That means this part, whenever this part is 0, so for that value of x, the expression will become undefined. So for each integral values of x, that is integers. So for each integer, this expression will be undefined. So here, except any values for any value of x, except integer for any value of x, this will be defined. So real number minus z. For integers, for all the integers, this expression will become undefined. Right? So integers we have to exclude. That's why we are subtracting here. Next one, log of x square minus 9 mod of x square minus 9, right?
Sir, option A.
Option A. So here log mod x square minus 9, right? So first of all, this is the argument of log. So this argument of log should be greater than equals to 0, right? So this modulus should
Right?
be greater than, no, not equals to, sorry, not equals to 0, only greater than 0. Argument should be a positive real number, right? So here for what values of x, this is always 0. So as you can see, this is always greater than 0. So x square minus 9 is 0 only for x equals to plus minus 3, right? So for x equals to plus minus 3, this expression will become 0. For other values of x, as you know, modulus is always a positive number, positive or 0 number. So modulus, this modulus x square minus 9 should not be equals to 0. If it is not equal to 0, then always log will be defined. So for these values of x, this expression will become 0. right? So here for only r minus 3 comma 3, these values of x, the log will be defined. Log is defined, then x is acceptable, right? So this is the domain. This argument should be greater than 0, not equal to 0. So as you know, mod is always a positive number, right? But this
Yes, sir.
value x square minus 9, this can be 0 also. So for we have to find the values of x for which this expression is 0, right? So we have plus minus 3. If you put either plus 3 or minus 3, this expression will become 0. So this is plus minus 3 is not the part of domain. All other values are the part of domain. So this first option is correct. Next one. This question, domain of this expression, 1 upon
Sir, option D.
1 upon x square minus 4. Yes. So
Option
again,
D,
root is
sir.
given there. So that means x square minus 4 should be greater than equals to 0, but it is written in denominator. That's why this should not be equal to also. So x square minus 4, this should be only greater than 0. So when this expression is 0, then factorize this x plus 2 greater than 0. Greater than 0 is there, quadratic equation is there, answer will be beyond the root. So minus 2, here plus 2, answer will be beyond the root. 2 to infinity, here minus infinity to 2. This will be your answer. So D option is correct. Right? Quadratic equation and greater than sign, that means beyond the root. Quadratic equation less than sign between the roots. Right? Fifth question. This mod is given.
D, D, sir.
And we have to find domain.
Real number
This
சொல்லிருந்தா sir.
expression is always defined. Right? Mod x minus 2 minus mod x minus 5. This is always defined. You can put any value of x. This will give you some value for fx. Right? If you take any values of x here and here, you will get some values of fx definitely. You will not get undefined for any real values of x. Right? So this expression is always defined. There is no problem for any value of x. So domain is real number. Right? So its domain is real number. Why? Because we can put any value of x. Like in question number 4, I cannot put x equals to 1 here. X equals to 0, I cannot put any value between minus 2 and 2. We cannot put here because this will become negative number. Root of negative number is not defined, not a real number. Right? That's why for domain means we have to find out only acceptable values of x. So now question number 6. Domain of the function, this one. So 1 upon fractional, again it is not, yes, it is given here. This box, this bracket is a fractional part of x, right? So see in the question, if any this curly bracket and box means square bracket is used, that means if that square bracket is representing greatest integer function, like if this curly bracket is representing a fractional part of x, then this
D, sir.
statement should be
Option D.
present. This type of statement should be present. If statement is not given, these type of function will be just normal brackets.
Option D, sir.
D. So again, this is sine fractional part of x plus here. What is sine pi plus x?
Minus sign x.
Minus sine, right? So 1 upon. So also we have discussed mod x fractional part of x minus fractional part of x plus, sorry, here. This type of question we already solved. What is the value of this one? minus fractional part of x, right? What is the value? Anyone got the answer?
1 minute, sir.
This.
Count on this. Fixed on option D, sir.
Option D.
Yes,
Sir,
sir.
for 0 and 1 only, it will be 0, sir. Both of them.
For x,
Whatever the
x
values
equals to 0, this will be 0. And fractional part of x is always a positive number, right? So fractional part of x is always a positive number. Fractional part of x is always a positive number, right? So fractional part of x here. Fractional part of x, value of fractional part of x is 0 to 1. 0 including, 1 is not included, right? So as you know, this is always positive. If x is defined, whatever function is written inside this bracket, if that is defined, then it will give you a number between 0 to 1, right? That means whatever value we will get from this bracket, that will be between 0 to 1, right? Here also, whatever function is written there, we will get value here between 0 to 1. This bracket also will give a number between 0 to 1, right? So only we have to check when these two functions are together 0, right? For which value of x, this denominator is 0. That we have to exclude. For except that value, right? Each value will be acceptable here. So when these values are 0, right? These two brackets, these two functions. Now see. So overall function we are getting sin x plus this plus. So here minus of sin x. Now if I put x equals to 0, how much we will get? Here sin 0 is 0, right? So this is root 0 plus 0. That is, you will get overall 0. 1.0 is undefined, right? Now, next, is there any other value? So suppose if we put here x equals to pi by 2. So sin, what is the value of sin pi by 2? So
One,
sin pi by
sir.
2 is 1. So what is fractional part of 1? This is also 0,
0.
0.
right? This is also 0. So that is for x equals to pi by 2. This is not acceptable, right? Because this will become 0 and this both these brackets will become 0 plus 0. And if you are getting 0 in denominator, that means that value of x is not acceptable. So for x equals to n pi and for x equals to odd multiples of pi, n pi by 2, both are not acceptable. As you know, so if I put here x equals to any value, 1 minute. So now, what is overall answer for this x and for this x, this x? So if I write down here x equals to n pi by 2, here n is any natural number. So suppose natural or whole number, right? Or for positive side and negative side. So we can take integer here, right? Because positive side, both number we have to cover here. So this will become, if I take x equals to 1, n equals to 1, 2, 3, 4, 5. So n pi type value also will be covered. And odd multiples of pi by 2, that also will be covered, right? So if we are using n pi by 2, that means n pi type number already will be covered here, right? And odd multiple of pi by 2, both will be covered here, right? So now let's check the answer. So yeah, D is the correct answer, right? Next,
Sir, seventh one option B, sir.
seventh one. Okay. So this is
7,
log
sir.
of 7
I shared
log
the
x.
solution, sir.
Okay, I will check it. For question number 7. So first of all, this log should be defined. Right? We have to find the value of x here. So this log should be defined. So log is defined for x greater than 0. If x is greater than 0. Right? Now if x is greater than 0, then also, as you know, for this log 3, the value of log of x with base 4 also should be 0. Is for this base 3, sorry, for this log for which base is 3, argument of this log also should be a positive number. So that means this is the argument of this log for which base is 3. So this also should be greater than 0. So first of x should be 0. Second thing, log of x with 4, base 4. This also should be greater than 0. Right? Again, for this log, argument of this log, that is this one. This also should be 0. Like log of x with base 4 and here base is 3. This also should be 0. So you have to solve these three inequalities.
Sir, I shared the solution for that, sir.
Okay. Yes. Okay, solve these inequalities. If these inequalities are correct, then you will get solution, overall solution. Right. So first of all, this log of x with base 3, 4, 3, and this one I think 2. Right. So first of all, this x should be a positive number. Right. Then second, this log of x with base 4 should be also positive number. And then again, log of x with base 4, this also should be positive number. So there are three inequalities, 1, 2, 3. Right? We have to solve these three inequalities only. Now see. So let's solve this one first. So this is 4x is greater than 4 raised to 0. That means x should be greater than 1. Right? How we are solving? We have explained one property, three property I have explained in the class. So third property was based on this one, I think. Log of b with base a. If this is written greater than c, then we can write down b greater than a raised to c if a is greater than 1. So as you can see here, base is greater than 1. So we can write down this is argument greater than equals to this base raised to index. So this base raised to index 4 raised to 0. So x would be greater than 0. Now solve this inequality. So for this one, this base is 2. So this is argument of base. So we can write down here log of x with base 4 greater than 2 raised to 0, right? So here we will get log of x base 4 greater than 1. So again we can use the same property. So x would be greater than 4 raised to 1. So x would be greater than 4. That means 4 to infinity, right? Note it on this solution. Next question, question number 8.
Sir, option A. Sir, option A.
Option number A. Option number A, log 2 5. Okay. So find the value of x for if the function is not defined. We have to find the value of x for its function is not defined, right? That means we don't need to find the domain. We need to find the value of x. We need to find value of x which is not domain. So also the question is 1 upon 2 raised to power x minus 5, right? So this function is undefined, then when this expression is 0. So that means 2x minus 5 should be equals to 0. Why? If the 2x minus 5 is equals to 0, then this expression will be undefined. So this we can write down 2 raised to power x equals to 5. So this expression we can write down for x. So this we can represent in the form of log, right? Also we can say taking log both sides. This also we can say. While taking log both sides, you will get log of 2 with base 2 equals to log of 5 with base 2. So this will become 1. So x is equals to log of 5 with base 2. This is the value of x. For this value of x, this expression will become undefined. So this is our solution. Next one. Yes. So now domain of this number. What is the domain of this number? That means base means there is variable in the base, right? So base
9
should be
point
positive
option
number.
B.
Yes, base should be positive number and base should not be equals to 0.
1, sir.
Oh, sorry, 1. Right? Base should not be equals to 1 and base should be a positive number. Right? So here this log 12 be with base x. So base should be greater than 0 and base should not be equals to 1. Right? So base should be between 0 to 1, union 1 to infinity. So this is the domain. For this value of x, this log will be defined. So B option, right? Second question number 10. Domain of fx equals to cot x by 3.
C, sir. Option C.
Option C. Okay, right. So here cot x by 3. Cot x by 3. Actually, what is the domain of cot x? Cot x, what is the domain? So cot x is not defined at x equals to n pi, right? So whatever values of x are given, we have, because here x plus x by x upon 1 by 3 is given. So we have to divide this number by this number, that is 1 by 3. We have to divide all these values on the x-axis for the graph of cot x. If we divide all these values by 1 by 3, then we will get the graph of cot x. So cot of x by 3. So whatever number is given, divide by that number. So x equals to 3 n pi. This will become x equals to 3 n pi. So this expression will not. Also, you can just check here. This is cot x by. This is cot x by 3, right? When when this expression will become 0. If I put x equals to 0, then cot 0 is, right, undefined. So again, so cot x is undefined at 0, pi, right, 2 pi, 3 pi, like these numbers. So again, if I put x equals to pi here, no, not pi, for which value of x this will become pi. So if I put x equals to again 3 pi, right? So 3 pi by 3, this will become pi. That means this value of x should be multiple of 3, right? So this option is correct. So r minus 3n minus 3n pi, right? This 11, question number 11. Question number 11. Mod x plus
Sir,
x.
option B, sir.
Option B is. So see, if I put x equals to -5 here, mod of -5 and -5. So mod of -5 is plus -5. This will become 1 upon 0. That means for negative values of x, this will, every time this will become 0. So negative values of x are not included in domain. So here we can put only here 0 to infinity. In mod x plus x, we can only put 0 to infinity. 0 also we cannot put. So if I put x equals to 5, so mod of 5 plus 5, this is 1 upon 10. So 1 upon 10 is a defined number. Right? So again, question number 11. Question number 11. Then find domain separately and take intersection. Domain of cos inverse x is -1 to 1. That means 1 minus 2x should belongs to -1 to
C,
1.
sir. Sir,
Hmm.
option C,
Option.
12.
Okay. So here, first of all, this root should be defined. That means 1 minus 2x without root. 1 minus 2x should be greater than equals to 0. Right? So x should be less than equals to 1 by 2. That means minus infinity to 1 by 2. Now next solution. So when this cos inverse x is defined, when value of its argument, that is here 1 minus 2x, if it is less than equals to 1 and greater than equals to -1, right, then cos inverse x will be defined. So here we can take one with this side. So this is -2 less than -2x less than, if I send this side, this will become 0. So again dividing by -2 both sides. So this will become x less than equals to 1 and greater than equals to 0, right? So that means x belongs to 0 to 1. Right? Now take intersection. 0 to 1 and half to infinity. So what is the intersection? 0
Option
included
C,
to,
sir.
yes, half. This will be the intersection.
Sir, 13D.
13. See, 13 is also based on inequality. This x minus 2, x minus 1, x minus 3 should be greater than or equals to 0. So just draw a number line, draw all the roots on number line, then take plus minus sign. All positive sign will be the solution. So x minus 1, x minus 2, x minus 3. This should be greater than or equals to 0. Then only root will be defined. So now draw a number line 1, 2, 3. Sign will start with plus 1, then minus, then plus, then minus. So positive 1 is the solution. Where I am writing here plus sign. That plus sign region will be the solution. So this one is the solution. This range and this range is the solution. Why? Because I am writing here plus sign. And this greater than means plus sign. So 1 to 2 both are included. Union 3 to infinity. This is the answer.
Sir, 14th one I sent the solution, sir.
Okay, I will check it. One is, so first of all, this 1 upon x
5.
will be defined, right? When 1 upon x is defined, real number except 0. So this expression is defined for real number except 0. Right? So domain of this expression is real number minus 0. At x equals to 0, this 1 upon x will become undefined. So 0 is not included in the domain. 2 raised to sine inverse x when this expression is defined. Right? 2 raised to sine inverse x. So just you need to take the domain of sine inverse x. So domain of 2 raised to something is always defined. Right? So only sine inverse x should be defined. So here x belongs to minus 1 to 1. Then only sine inverse will be defined. So domain of this expression is this one. When this expression is defined, when x minus 2 is greater than equals to not equal to 0, because it is written in denominator. So greater than 0. So when it is greater than 0, when x is greater than 2. Now you need to take intersection of both the solution. What is the intersection? Intersection of these three sets. 14, you have sent the solution also, right? Yes. So what is the intersection? As you can